So welcome to the DK Institute of Mathematics. So please like and subscribe my YouTube channels. So आज के लेक्चर में हम क्या देखने वाले हैं कि एनालिटिक फंक्शंस. दिस इज वेरी इंपॉर्टेंट टॉपिक फॉर दिस CSR, NET, GATE, SET, other examinations. Such a important chapter. What is analytic function? Before start analytic function, some basics are start. The first definition: limit of a complex function. Limit of a complex function. Suppose that a complex function f is defined in related neighborhood of z0, and suppose that L is a complex number. The limit of f as z tends to z0. The limit of f z tends to z0 exists and equal to L. Written as limit z tends to z0 f of z equal to L. If for every epsilon greater 0, there exists a delta greater 0 such that mod fz minus L less than epsilon, whenever 0 less than mod z minus z0 less than delta, is called as a limit of a complex function. It's called a limit of a complex function. The second criteria for the non-existence of a limit: if f approaches two complex numbers L1 not equal to L2 for two different curves or paths through z0, then limit z tends to z0 f of z does not exist. Then limit z tends to z0 f of z does not exist. This is called as criteria for the non-existence of limit. The next definition: continuity of a complex function. A complex function f is continuous at a point z0 if limit z tends to z0 f of z equal to f of z0 is called the continuity of a complex function. A criteria for continuity at a point: a complex function f is continuous at a point z0 if each of the following three conditions holds. Each continuous at a point z0 if each of the following three conditions hold. The first condition: limit z tends to z0 f of z exists. Limit exist होना चाहिए. The second, f is defined at z0. F is defined at z0. And third, limit z tends to z0 f of z equal to f of z0. This is the criteria for continuity at a point. The next definition: differentiable function. The function f of z equal to u plus iv, that is u means two variable x comma y plus iv x comma y, is said to be differentiable at a point z equal to z0 if f of z is continuous at z equal to z0 and its limit, that is f dash z equal to limit z tends to z0 f of z minus f of z0 upon z minus z0 exists. This is the differentiable function. The result 1, a necessary condition for differentiability. If a function f of z equal to u x comma y plus I phi x comma y is differentiable at a point z equal to x plus iy, then the first order partial derivatives of u and v exist and satisfy the Cauchy-Riemann equations, that is CR equation. What is the CR equation? Do u by do x equal to do u by do y and do u by do y equal to minus do u by do x is called as the Cauchy-Riemann equation, that is CR equation. Result 2, if a function is differentiable at a point z equal to z0, then CR equation hold at that point. Or if CR equation does not hold at a point, then functions cannot be differentiable. Function cannot be differentiable at that point. Result 3, sufficient condition for differentiability. If the real functions u x comma y and v x comma y are continuous and have continuous first order partial derivatives in some neighborhood of a point z, and if u x comma y and v x comma y satisfy the CR equations at z, then the complex function f of z equal to u x comma y plus I phi x comma y is differentiable at z, and f dash z equal to limit z tends to z0 f of z minus f of z0 upon z minus z0. Result 4, If a function f of z equal to u x comma y plus I v x comma y is differentiable at a point z, then its derivative is given by f dash z equal to ux plus I vx or f dash z equal to vy minus I uy. Result 5. Different form of CR equations. Following are the different form of CR equations. The first, if fz equal to ux comma y plus I v x comma y, then CR equations are dou u by dou x equal to dou u by dou y and dou u by dou y equal to minus dou u by dou x. Second, dou f by dou z bar equal to 0, where z bar equal to x minus iy. Third, I f of x comma y equal to f of y x comma y, where f of x comma y represent the partial derivative of f with respect to x and f y x comma y with respect to y. Result 6. Polar form of the CR equations is dou u by dou r equal to 1 by r dou u by dou theta and dou u by dou r equal to minus 1 by r dou u by dou theta. We start the definition of this important analytic functions. What is analytic function? A function f of z equal to u plus iv is analytic at a point z if f of z is differentiable at z as z as well as in some neighborhood of the point z is called as the analytic functions. What is the next definition? Holomorphic function. Holomorphic function. A function that is analytic throughout a domain D. A functions that is analytic throughout a domain D is called holomorphic function or regular function. The definition, entire function. If a function fz is analytic in the whole complex plane, if function fz is analytic in whole complex plane, that function is called the entire function. That function is called entire function. Result 7. If a function is analytic in domain D, then it's infinitely many times differentiable in domain D. The example show that dw by dz equal to dou w by dou x equal to minus I dou w by dou y, where w equal to u plus iv is an analytic function. The solution, by using Cauchy-Riemann equations, we have dw by dz equal to ux plus I vy, ux plus I vx equal to vy minus I uy. That is equation number 1. Now since w equal to u plus iv, dou w by dou x with respect to the differentiable x, dou w by dou x equal to ux plus I vx, that is equation number 2. By equation 1 and 2, we obtain dw by dz equal to dou w by dou x. Further, dou w by dou y equal to dou uy plus I vy. That is minus I dou w by dou y equal to vy minus I uy. That is equation number 3. By 1 and 3, dw by dz equal to minus I dou w by dou y. Thus we have dw by dz equal to dou w by dou x equal to minus I dou w by dou y.